Good evening for those of you in Europe who are here. So as people join, I'll just let the audience know we're going to be discussing all things wireless EV charging. We'll also discuss charging bots wirelessly. We'll be taking questions from the audience. So when you have a question, just request to speak, and we'll bring you up. We're also recording this video, or this space. So for those of you who can't stay for the whole thing, welcome to join again and watch the replay later. So Jeremy, while we wait for people to join before we get into kind of charging cars wirelessly and Tesla's acquisition of Wiferion, maybe just tell us a little bit about yourself.
Yeah, my name is Jeremy McCool. I'm the founder and CEO of Hevo. It's a wireless EV charging company headquartered in New York City. We've been doing this since 2011. I started the company out of Columbia University, where I was doing my master's on urban policy and a focus on sustainable development. Before then, I was in the military. I served as an Army captain, led troops into combat into Baghdad, have been a entrepreneur for my majority of my life, and really think that it's an important time for wireless EV charging, where we start to see this technology finally move from fringe to trending. And we're going to have a lot to talk about today, not just about the science and the engineering behind what makes wireless charging work, but the importance that it's going to play in the acceleration of electric vehicle adoption and modernizing the grid. And so it's a really important topic to be discussing today, because so much evolution is happening right now in electric vehicles, period. And with the new release of the new version for FSD, plus all the things that are being finally worked on for Robotaxis, plus with the acquisition of Wiferion by Tesla, and plus every other major automaker in the world trying to find ways to be competitive in this new emerging industry, it's a very, very hot topic of choice right now. So it's going to be a good one.
Yeah, well, let's maybe we'll start with a couple basic things. So whenever I talk wireless charging, people get excited, especially people like my wife who don't really love plugging in their Tesla, a couple times a week. The biggest issue that people tend to bring up is, well, isn't it going to be a lot less efficient than plug-in charging? Aren't you going to be wasting a ton of electricity? So maybe if you could tell us a little bit about the efficiency compared to a standard level 2 charger as well as a supercharger.
Yeah, it's an ongoing, recurring type of theme that I see, especially in the comments on social media, and it's an understandable one, because when most people think about wireless EV charging, they typically think about wireless charging for their phones. Undoubtedly, there is some energy loss difference between plug-in and wireless charging, especially in those kinds of appliances. But when we're talking about electric vehicle charging, we're talking about a different type of technology, and that is that we use electromagnetic resonance. So we resonate two coils, if you can call it a transmitter and a receiver, on a select frequency, and that frequency for wireless EV charging is 85 kilohertz. That's the universal standard globally. What's important about that is that makes it universal in the way that wireless charging can work for your phone. But the difference is that because we do resonate, it has less efficiency loss as a result. Why? Well, there's a few things. A few years ago, you could argue that wireless EV charging was less efficient because of the type of components that we had available to us in the market at that time. One of those being the switches or the semiconductors. The semiconductors were not as efficient as they are today, just even 4 or 5 years ago. And a lot of that has to do with computer-based models that need more storage to be able to run their computations. In other words, cloud storage has helped a lot with wireless EV charging efficiencies because of the type of switches, whether they're IGBTs or 6 or whatever they might be, have been radically improved to improve the efficiencies for those kinds of industries. And it's given us the capability to take advantage of those advancements that have led us to having as high as 95% total efficiency from grid to battery. When you compare that to a plug-in charging station, the max efficiency from grid to battery that you're going to see is approximately 96, 97%. So we're near parity, if not at parity at this point, with the max efficiencies between wireless and plug-in charging. And that's pretty defined now across the board for almost anybody that's doing wireless EV charging. You're going to have to be in the 90 plus percentile in order to make it work. And in fact, it's funny, Matthew, there's an older interview where Elon's on stage. One of our advisors from our board of advisors, his name is Roger Atkins. He has a pretty large EV related following on LinkedIn. He asked him a question. This was got to be 7-8 years ago. Are you interested in wireless EV charging? And Elon straight up said no because of efficiency. And he was right at that time. The efficiency was more in the 80, 85 percentile at that point. But now we get tested regularly by major automakers in third-party environments, national labs. We know that the efficiency is no longer a critical point. And in fact, I would just say that there's no longer a technological risk to wireless EV charging when it comes to efficiency and safety and these kinds of administrative types of effects. It's now a matter of how do you scale wireless EV charging effectively to get a price point and to get it into a certain kind of weight configuration that works for an electric vehicle platform. And of course, who else is doing it? And it's a good point to say that Tesla's doing it now.
Yeah, that's great. So to summarize for the people just joining, Jeremy has been explaining his background, why he started Hevo, and talking about efficiency with wireless charging. So it appears that wireless charging is about as efficient as plug-in charging. You know, might be a couple of percentage difference, and so that's going to be pretty surprising to a lot of people. So Jeremy, last summer when we were watching the Tesla annual shareholder meeting, there was a slide in the deck. It showed a red Model S Plaid in a garage, and on the wall was what appeared to be, you know, a high power wall connector with a cable going to a pad underneath the car. And so as soon as I saw that, I was like, oh wow, that's a wireless charging pad. This was before Tesla announced the Wi-Furion acquisition. Tell us what ran through your head when you saw that image.
I was elated. That's the most important word, because the three things that matters to automotive adoption. So you have to have automakers accept wireless EV charging or it never takes off. It's a requirement. If an automaker is looking for wireless EV charging, there's only a small handful of us in the world. We're talking about a very niche group, and it's taken all of us a decade or more to make our technologies meet the size, weight, pricing requirements of automakers, but you still have to get them to adopt. And traditional automakers are not first movers. That's not what they traditionally would do. They're very conservative. Largest automaker in the world, Toyota, a very conservative company. Volkswagen, very conservative company. They know they must meet certain objectives technologically to try to keep up with the advances that are happening at almost lightning quick speed right now. And it's completely changing everything that's happening in the industry, especially around electric vehicles and FSD and all these other things that are happening on the autonomy side. But whenever I saw, and you know, I should say all of us, when we saw that interesting slide, the most important thing was who was presenting it. Not necessarily just that it was an image of what looked like a wireless charging pad underneath the rear axle of the Tesla Plaid, but who was presenting is a person named Rebecca Tanucci. And see, Rebecca Tanucci used to be known as Rebecca Huff, and her father, Tom Huff, was one of the original people that helped to launch wireless EV charging. The name of the company back then was called Evatran. It changed its branding name to Plugless Power. And it was around the summer of 2018 or so, between that and 2019, that Rebecca, as CEO of Plugless Power, because she became the CEO of that company, made a decision to step off of Plugless Power as a CEO and go to Tesla. And we had friends working on EV charging on that side, and I'd every once in a while hear about Rebecca being involved with the electric vehicle charging platform, and then all of a sudden saw her on the Investor Day presentation and showing a slide that said, and you need to do things that are cool, basically, to paraphrase it. So a person who has remarkable history and experience in wireless EV charging, who is now responsible for global EV charging for Tesla, has a responsibility to present on wireless EV charging as a Easter egg kind of thing. And now this company has made the decision to acquire Hyperion about 6 months ago. I think those things all lined up pretty well.
Yeah, I had a similar reaction. We do have, some people requesting to speak. We are going to get to questions pretty soon. We have quite a few people on the speaker board. Emmet Peppers is one of them. Emmet and I have long been following Hevo, and Emmet, I'm not sure if you can say the whole time, so why don't you come and introduce yourself and let us know if you have any questions for Jeremy.
Yeah, I've been listening, Jeremy. You've been spouting out amazing information that is very interesting to me. I'm vested to see your company succeed. If anyone doesn't know, and I'm rooting for you, and I think you're an incredible entrepreneur, and I think there is a very good use case, as you described, for wireless charging, and how the grid efficiency is, very close to wired charging at this point. The only main difference, I think, that is the speed, right? The only that can't really be overcome, but that doesn't, there's still a ton of use cases, even without the super high speed charging that wired charging allows. Is that right, Jeremy?
Hi, Emmett. Good to catch up with you. Actually, speed is not a blocking situation for wireless charging. There are companies out there that have tested even at 500 kilowatts for wireless EV charging with actual vehicles today.
Really?
And
oh wow,
yes,
that's new to me.
So there is no blocking obstacle between wireless and plug-in charging in the form of the technologies that way.
Doesn't the heat have to dissipate and because it's can only be 97 or 95%, 5% of the heat is lost or something like that, and so at a higher rate of charge, isn't that 5% much higher and it melts things or something? Isn't that the reason people used to think at least speed was a limitation?
Yeah, so there is going to be loss, and there's going to be thermal related heat requirements that have to be met. So how is that done? Mm-hmm. Well, if you look at wireless charging, there's 4 stages of it for transferring power. You've got the primary stage that's connected to the grid. That thing can be called a wall box. It can be called a pedestal. That is cabled to a transmitting pad. That transmitting pad looks like generically like a manhole cover that you could see like composite manhole covers that you see all around cities. Call it 1 meter by 1 meter. So it's a kind of either a circle or a square. And it's going to be somewhere between 1.5 to 3 inches thick, depending on who's making it, etc. On the vehicle side, you've got the receiving pad, and that's a much smaller version. Actually, it's not the 1 meter by 1 meter squared pad, that transmitting pad that you would see on the ground or in the ground or flush mounted into the ground. It's about 40% the size of that. So it's somewhere going to be in the range of like, call it 40 cm to 40 cm. The size of a medium-sized pizza box is a good way to think about it visually. And then the final stage of it is what's typically known as rectification. It's a conversion from AC to DC. So we spout out DC directly to the battery. Along those stages, you're going to have somewhere on average for each stage, you're going to have somewhere around 0.5% to 2% loss. That's how the calculations work. So in the first stage, you might have 1.5% loss. Between the second stage, the transmitter and the receiver, you might have 0.5%, maybe 1% loss. And then the third stage, or the final stage, the fourth stage, I should call it, the rectifier that goes from AC to DC, that's going to be somewhere between 0.5% to 1.5%, depending on how the architecture of the technology is. So you're actually dispersing the heat out to all these different stages. And by doing that, you're not going to see the heat signature. In fact, we have done tests where our pads don't change from ambient temperature at all, even for high power systems. And so where is the most power heavy components going to be at? They're going to be on the first and the fourth stage. The part that's connected to the grid, the wall box or the pedestal, and the part that's converting from AC to DC. And those are the two parts that have the most efficiency losses as general. And so the one that's on the vehicle side, if it's on a lower power spectrum, meaning 11 kilowatts or below, you could even argue it can go up a little bit higher than that, but 11 kilowatts or below, it's passively cooled. You don't have, because it's you're talking about like 1.5% of loss. You know, call it a budget of 100 watts to 200 watts of heat. You can do that passively all day long through a heat sink and some generic automotive grade fans. When you get into the higher power, 50 kilowatt, 300 kilowatt.
How do they handle that? Yeah.
It's liquid cooled, just like the batteries are. So you're bilging from the liquid cooled side. And by the way, automakers do this for other components on the vehicle that are power parts. That's how automotive companies have been able to improve total efficiency of systems on powertrains, because they already have the liquid cooling already built into the battery packs. And as a part of that, because that has to stay cool, otherwise you get the dendritic runoff and then the batteries catch fire and there's no way to put those out. You just got to let them burn out, right? So with this, we're basically tapping into the existing, call it coolant line, that automakers provide to us as a way to run a liquid cooled system through our rectification. It's a standard automotive grade type of application. There is nothing about that is strange. That's actually the way it needs to be done. So commonly, by the way, I'll just point this out. Commonly, the plug-in charging onboard charger, the plug-in OBC, they also get liquid cooled for the higher power systems to keep them also from having thermal runoffs as well. So this is not abnormal. This is exactly how these systems get implemented. And so we don't see a staged up heating process that leads to anything meltdown. Nothing like that, not even close. We've had to be qualified through the Society of Automotive Engineers, SAE committee, has very specific standards to all this. And also we've been the only company that has not only qualified SAE for wireless EV charging, we're the only company that's done that, and Underwriters Laboratories, their UL certification. So we are the only known SAE UL certified and qualified technology in the world. And we have, as far as we know right now, the only UL certified facility for producing these kinds of pieces of technology, which is in Brooklyn, New York right now. But I would have to say that there is another company that did get UL certification. They're tier 1 out of Australia. The name of that company is Lumen. The name of their wireless EV charging program is called Lumen Freedom. But from what we understand, they've completely dissolved that. So they were the only other known UL certified technology in the world. They don't seem to be doing it anymore. And it's possibly because of what you kind of brought up. They had a different type of architecture that was leading to heating up with a higher budget of thermal budget that they just couldn't cool. But that's
Couldn't dissipate it.
just hearsay, right? So I just want to make sure
Hmm.
that that's only hearsay. I can't confirm
Yeah.
if that's true or not.
Interesting. Thanks for the explanation.
We should talk about cost.
Yeah. Matthew, do we want to have one of the other speakers that you brought up ask a question first, real quick, just to
Yeah,
keep it.
sure. So the other speakers that are here, unmute yourself if you have a question. Those of you in the audience, feel free to request to speak, and we'll bring you up.
All right. First of all, I have to check if this works. Can you hear me, guys?
Loud and clear.
Yeah.
Perfect. Okay, because I'm connected to my Tesla right now, my new one, the Model 3 Highland. So yeah. Interestingly enough, when I've heard also the news about Tesla acquiring this great wireless startup, yeah, I was not surprised that it was a German company, because they were located south of Germany, here in Freiburg, and yeah, we have highly specialized great companies, small and medium enterprise companies, as you know. For example, also Gromon Automation was acquired by Tesla. For that, they are super helpful for the battery production, of course. And yeah, there are so different concepts about wireless charging around. For example, in Japan, they tested when you go to the, for example, as a use case, where to put those wireless chargers, of course, on the red lights, on the traffic lights, when you stop, that your car is charged. And we also seen some concepts of, yeah, maybe a road is paved with a coil, more or less, with many coils. But the cost, talking about cost, I think this one kicks it out of the ballpark. So my question would be, in which direction, from the cost perspective, from the use case perspective, would be the best use case for using the wireless chargers? Should we go bananas and put them into the pavements? Does that make sense or not? And yeah, that's one big question I had.
Yeah, the use cases, there's a fundamental argument that fleets are where you're going to see wireless EV charging be probably the most expedited version of deploying it commercially with. That's a fair point, by the way. I would tell you it has a lot to do with the efficiencies of just ensuring that the fleet is operating without any friction points. Something that a lot of people just don't even think about is that fleets have a lot of the predetermined requirements that are not usually known, actually. And one of those are around the point that there is union labor agreements that restrict these kinds of fleet drivers from being able to even fuel up their vehicles. And by the way, plug-in charging is on that same list. So they have to have charging attendants standing ready. And I'm talking about major fleets, major last mile distribution, major trans. These kinds of fleets have charging tenants hanging out, paying them $100 per hour to just plug in cars. And it's a pretty challenging problem for them to resolve without wireless charging. We have a major utility in this country that ran an independent study to try to figure out if there was going to be a cost savings for going wireless versus plug-in charging. And their independent study came back that if they had 1,000 vehicle fleet that was fully electric, that they would save on average $300 to $400 per year per vehicle for wireless charging. And so $350,000 of excess cost, though, in addition to that, because all the plug-in charging, cable management, replacement things that they would have to do. So they put a kind of price tag on it. They said, hey, if we had 1,000 vehicles in our utility fleet that were fully electric, we would be able to save $350,000 per year. You add that plus, then they took a next step into that study and they said, well, what if we did a bi-directional as well? Well, we get the benefit of being able to transact energy back and forth and arbitrage that in a way that we could save money on our cost of energy. And their independent internal study said they would save an additional $3 million per year. So total in, they're saving over $3 million, almost $3.5 million a year by having level 2 wireless charging that's bi-directional versus having unidirectional normal plug-in charging because of the elimination of all these inefficiency points. It's quite literally a 10x situation for them. And you could imagine they want the wireless charging as a result. There's another fleet that we have been building a relationship with over several years, and they predominantly service to people with disabilities, people that have upper and lower mobility challenges, and they have a massive fleet. We're talking about a fleet of over 500,000 vehicles that they're responsible for providing these kinds of services to disabled drivers for. And when they look at the numbers, they would have to basically hire people to go out to people's homes to plug in for them. And it's a big number. It's like 50% more than of their drivers would require it. And they have a responsibility. They have a requirement by their government to go all electric by 2030. And it's a massive problem for them because they started to switch people off from internal combustion engine vehicles, ICE vehicles, to electric. And they're having to send people to individual homes to go plug in the cars for these people because they can't do it. And we take it for granted that it's just so easy to plug in. Yeah, for a normal person that doesn't have a disability, that isn't carrying a bunch of kids around, all these other things, fine. That's the truth. Can't argue that. But that isn't normative, actually, it turns out. It turns out that the world is really complex and there's a lot of challenges to this thing all around. Now, from the individual side of this, we have two major automakers that we're involved with for programs that are not Tesla, by the way, that are moving towards a wireless charging series production system. And that would be associated with predominantly the use case being for passenger vehicles. You could argue that they're starting in the luxury brand of their vehicle models, but what model of electric vehicles aren't really considered luxury today? So I think that's another philosophical point. However, not to digress on that. The point is that we have seen the minimum order quantities, and we know that you will be able to buy vehicles that are not just Teslas, but other vehicles with wireless charging in the next couple of years because of their start of production. So use cases are going to be unique. There's fleet and there's home.
Yeah, let's get into kind of cost for an owner adding EVs, wireless EV charging. But before we do that, a couple things. So again, we've got some new listeners now. So any new listeners who have questions about wireless charging, please raise your request to speak and raise your hand. I wanted to talk about another use case. So a friend of mine is the CFO of an EV kind of light duty and heavy trucking manufacturer. So they make things like garbage trucks and ambulances and fire trucks and things like that. And they have a client in New York that's a big garbage collector. And they have these depots where they park all the garbage trucks in New York. And, property is very limited in New York. And so they basically box in all of the trucks at night or when they're not running. So there's basically no extra room. And they're switching over time. They're switching to EVs. It's a mandate from the city. All these new vehicles essentially will have to become EVs. But running cables to where all these trucks are parked is very, very difficult because you'd have to have very long cables. So they're actually looking to add wireless charging pads because they can basically make the entire depot, covered with these coils, and then the trucks can charge, while they're all boxed in. You don't have to rotate them around, so one of them is closer to the charger.
Yeah.
Yeah. So again, I'll invite anyone else who'd like to speak. Please raise your hand. But yeah, let's talk about costs. One for the manufacturer, and then another one for retrofit. So if I'm Tesla and I have a single onboard charger for plug-in charging, what is the extra cost to add wireless charging to the vehicle? And maybe talk about look at it from a first principle standpoint. So what's the cost of the actual hardware, the parts of the hardware, not necessarily the manufacturing, because that will come down, as volumes go up. But just what's the actual cost of the materials that are going into that? And then the same question for the wall charger. You can buy a wall charger from Tesla for whatever, $400 or $500. If it had a wireless charging pad, how much more would it cost Tesla to manufacture that?
Tesla's going to do its own thing. So what I do know is that Tesla has, by the nature of their first principles, and we'll say their kind of battle rhythm that they call the algorithm that they're constantly monitoring around, with this whole cost and down, cycle up, automate approach will mean that in general, we'll see Tesla, because of the nature, also the size of their existing customer base and growing customer base, as adopters continue to buy into this as the prices come down, that the equipment on the vehicle side, it will just say total cost of just materials for everything on vehicle side and ground side for a home charger is going to be less than $650. Okay, so what they make a decision to do in terms of their pricing is going to be unique, because it's going to be unique to them. They operate in a vertical integrated environment, and we would only assume that, just like we've seen with some of the other upgrades and options that Tesla has done, with that, this is probably going to be packaged in with something else that they're packaging it with. I would say that you could see it being packaged with FSD as an example. So if you get the FSD package upgrade, you pay, instead of 12,000, whatever it is, now you pay 14,000 as an example. But now you don't have to charge a car, and the car also has bi-directionality on it. So now the car is supplementing your home as a backup device for vehicle to home. And that's not really outside the realm of very strong capabilities for them to be able to do. And I would tell you, it's within that same level of, because of first principles, there's only so much you can do to reduce cost, weight, and components and wireless charging before you reduce it down to a point where it's not wireless charging anymore. That's the same principle pricing structure that's being utilized for every other major EV company that we're involved with. So I can speak to what that part is, and knowing where probably things will lie with Tesla. They have a volume supply advantage because they're selling more cars than everybody else, but that won't always be the case. Our motivation in this, so everybody understands this, Tesla, yes, has a massive part of the existing market today, but our motivation is to supply all the other companies and get all the same order of effects, if not even greater, because the totality of all those rest of those companies and the total amount of vehicles that they're going to be selling over the next 3 to 5 years will be actually larger than Tesla's total as a group, as a summarization. So we are our advantage in this industry is we are the total integrator as an open platform. That's the vehicle side equipment as a tier one automotive supplier, the grid side, and also software that combines all these things together. We have an open based platform that allows for all the other automakers to have a supplier that they can purchase and build their platforms for it. And then we utilize the supply chains as common parts and components to price it significantly down in order to be able to achieve similar cost structures that you would see from Tesla.
Yeah, that's great for the manufacturing side. One thing is, today there are 6 million Teslas on the road. Do you ever plan to offer a retrofit where I could go out and purchase the hardware from you and have you install a wireless charging receiver on my Cybertruck and a charging pad at my home?
We're not seeking anything right now for Tesla because Tesla's on their own, seeking their own part of the strategy. We have done wireless charging for Teslas, but and I'll go back to this, Matthew. We have two automakers that we're developing wireless charging for them to release as serial production systems in future models in the next couple of years. That's where our focus is. Right now, we don't have an aftermarket focus where you can pull in a Cybertruck, at a location and go get it done, because frankly, there are no places to go pull in a Cybertruck to go do modifications at. That's one of the biggest challenges that is actually a real problem for Tesla in the modification side of the of that type of equation, versus the other side of it being all the other automakers have dealerships all around the world to be able to go do modifications at. And for them, and through their programs, we can offer aftermarket fits that people can go put on non-Tesla based vehicles, because it's already, the infrastructure is already there to be able to do it.
Yeah, makes sense. Okay, we got a question coming up.
Okay, so this is what I wanted to say real quick for Jeremy. Hi, it's Joe. I'm the president for Tesla NorCal as well as Central Valley, San Joaquin Valley. So I understand what you're saying about Tesla has their own solutions for everything, but as we know, Tesla doesn't retrofit. Tesla moves forward.
That's right.
So if you had something that could possibly work for like somebody who has like a 2018 Model 3 or a 2020 Model Y or something like that would be a great thing for people to purchase. We have over 4,000 members, and I'm pretty sure there's a small percentage of them that would love to do something like that. So I mean, I'm just saying, like, don't take it off the table, because there are DIY people, there are people that can possibly go to a mom and pop shop that does repairs and things like that, that can possibly do that for the person. So I mean, what I mean, like, I don't want you to take that off the table. I hear what you're saying, but you really have to keep in mind that Tesla moves forward, they don't move backward.
That's for sure, Joe. Really, really excellent point. That's why when I was saying modifications for a Tesla through some kind of form of an existing infrastructure that they could support doesn't make any sense. They don't do that. And so it would have to go through third-party body shops and people that would potentially do it as a DIY. First and foremost, we would love to be able to do it. I'm not trying to say that we don't have interest. Our interests are deep in trying to bring wireless charging forward and helping people to get it onto vehicles. There's no limitation to what we are willing to do to make sure that happens, or at least nearly no limitation. But we still have a really important challenge that must be met from the point of action to execute on that. And the execution is, we've gone as far as, so to just open it up on this, we've gone as far as to go all the way up to the legal chain of Tesla, even just a few years back, to get approved to be able to do aftermarket retrofits utilizing these third-party body shops that are Tesla approved. Okay, so everybody's tracking on this. So we went through that whole process. We went to all of their key people at Tesla to ensure that our product would be within their conforming requirements, et cetera, et cetera. And then we went as far as to get to a legal opinion of a very important matter, which is, will it revoke the warranty on somebody's car? Because if that's going to happen, then the exercise of this is going to be too high a risk for everybody involved with it. And so we'll just say that they were willing to speak to that point, but not write to it, meaning the Tesla legal team. If they would have written us and said, we hold no warranty voidance issues based on you doing your aftermarket, you could have had it on your car years ago from Hevo, because we've been ready with UL certification and SAE qualifications since 2020. We got those during the pandemic, even with all the challenges that we had to do to get them. So we went through the process to try to get a Tesla approved aftermarket solution. Not that we're not trying to still go that route. We have a lot of dealership style third party body shops that have all the infrastructure and capability to do those retrofits incredibly effectively without diminishing anything on the vehicle whatsoever. But they're unwilling to take the necessary step to do it, which would mean that it's because they haven't heard from the flagship, from the mothership, I should say, that they're not going to revoke somebody's warranty. And that's where the challenge is. It's specifically in that matter, Joe. So if there is anybody on here that has the capability to convince a very important person who happens to own Twitter or /X that aftermarket solutions for wireless charging can exist today, and it takes them just agreeing that we could do that, we would start immediately. Because I can tell you, we've already done our own Teslas of wireless EV charging integration and have seen how that works. We know how it would play out, but you're right. They don't go backwards. They go forward. You have to expect that it's going to be a product that is going to go on to new vehicles only. The question is when are they going to release that? So those are the two pieces to this. Is we would love to be able to service Tesla customers. We've got plenty of Tesla certified body shops who wish they could do something like this. They just don't have the green light from the mothership to be able to do it. And that's not to throw it on Tesla. By the way, they're making very informed decisions on their side. I'm not trying to treat them like the bad guy in that conversation. In fact, I'm just so happy to see them doing wireless EV charging. We all are, because it's validated that wireless EV charging is important. So if there's a way to come up with an answer on that, then we're ready to help solve for it. We want to be a company that people can go look for and provide that service. Thank you for that question, Joe, or that point.
Yeah, so if anyone wants to try and talk to the folks at Tesla about approving, aftermarket wireless charging, I think someone like Emmet would love to get wireless charging on his Cybertruck and drive it around Silicon Valley.
Does Emmet have the full FSD package?
So I think, by the way, Emmet might be dropping off. I know you have to get in the car. He has FSD on his other cars. I don't. FSD is not out yet on the Cybertruck.
Yeah.
But he does have it on his other cars, and he has the license for it. I will. We'll take a quick pause there to talk about Franz. So Franz gave an interview last year talking about the design for the Robotaxi. And he said there was a couple things that were really important for the Robotaxi. It had to have the ability for the doors to close themselves. So you take a Robotaxi somewhere, you get out of it and you don't shut the door. Then the Robotaxi can't really move. So that was one major requirement. And another requirement was the taxi had to charge itself. And so wireless charging is going to be a requirement for the Robotaxi. The Robotaxi is going to be built on the Gen 4 platform, which will be the cheapest Tesla ever made. So the least expensive Tesla will be the Gen 4 platform. We'll probably see something, start to be produced maybe late next year. And that vehicle or that platform, at least the Robotaxi version, will have to have wireless charging. So it would, probably make sense to include wireless charging on, the consumer version of that vehicle as well. So, we're not just going to see wireless charging on the luxury or more expensive vehicles. This is going to come all the way down market. I'll invite any other listeners who want to chat about wireless charging, but one thing we haven't really talked about is bots. So Tesla's building this Optimist bot, and I'm seeing a lot of projections of the value that a bot could bring to, say, a factory. So, if a factory pays a worker $25 an hour and that worker works for 8 hours a day, well, you could have a bot working for, say, 16 hours a day and charging for 8 hours a day. Well, if these bots all had wireless charging, maybe there's a wireless charging pad that the bot would stand over, they could essentially run 24 hours a day. There'd be zero downtime. Also, if they had wireless charging, the batteries on the bots could be smaller. So if the batteries were smaller, they could be lighter, they could be less expensive to build. It'd be curious to go through a calculation of, what size battery is going to be in a bot. You can look at all the other bots on the market, and see what size batteries they have and how much of the cost of the bot is that battery. It might be 5% or 10% of the total cost of the bot. Well, if you could cut that battery in half and add wireless charging, and the wireless charging costs less than the reduction in cost of battery, it would actually be cheaper to manufacture bots with wireless charging than without. So it'll be really interesting to see what comes from there. Jeremy, one thing I would also recommend, there's some aftermarket Tesla companies like T Sports Line or Unplugged Performance, especially like Unplugged, where they have a fairly close relationship with Tesla. So maybe you could come up with a retrofit for, say, the Model 3 and the Model Y, and you could have those shops sell the retrofit, and they could install them. They do a lot of installations in the Bay Area. And even if you said there's no guarantee this won't void a portion of your Tesla warranty, you know, there's people who will take that risk to try something new. So even though you might not sell a huge volume without that guarantee, it might be a good way just to show off the technology and bring more awareness and get more people interested in purchasing it in the long term.
Yeah,
Yeah,
Matt.
I would second that because sorry to cut you off, but because in our community, people mod their vehicles all the time. Damn the warranty. There's people who modded their Cybertrucks right away. So I wouldn't think that would be a problem or a hindrance for most people because you're talking about something that's going to add a ease of convenience or just pulling home and not even having to plug it in. Like that's an extra step that you don't have to take. Like that's pretty cool.
Joe, maybe you could talk a little bit about the X takeover this summer. Maybe if we could get a Hevo demo set up there where we have a Tesla equipped with Hevo's wireless charging and a charging pad. You could do demos of the wireless charging there, and there will be a lot of Tesla employees and representatives on site at that event.
Yeah, that'd be something you would definitely look into, Evo or Jeremy. You can speak with me. I am the director of partnerships for Silicon Valley, and so I handle all the partnerships and things like that. That we're trying to sign people up for, and that would be great to have the community experience Hevo in person. Like that event usually has over 2,000 attendees, and it marks a pretty special occasion throughout the year for summer. So yeah, if you could find a way to make that happen, I mean, it's in July, end of July, and it's in San Luis Obispo. So we could definitely talk offline. I'll follow you so you can hit me up in my DM.
Got it. We'll find out pretty quick on how this could play out in the form of aftermarket. I think that it's becoming clear that people want it, and we want them to have it. I would tell you from an aftermarket perspective, you could have probably assume an extra 50% cost because of the additional labor requirements to be able to do the installation, right? So there is that part of it. But at the end of the day, if people want it, we're not going to hold people back from getting it. We just been very clear of trying to do our best by the customer from day one, make a product that they care about and that they love. All right, fine. You got to do that as a result of just any kind of product that launches, but being able to do it in a way that's sophisticated and simple though at the same time so that they don't have to go through a lot of check marks and crossing over a bunch of barriers to get to it. So I'll ping you offline, Joe. We'll figure it out from there to see what can come together. I would tell you back to Matthew's point too. The Robotaxi is going to be by far the largest, I would guess you could technically say, selling car based upon, I think, the internal assumptions that we've seen and everything to this mix of different platforms that Tesla is going to be offering. And without a doubt, wireless charging is the cheapest, most efficient way to charge those cars. This idea of always topping up, or ABC, always be charging, that is really important to a point that you brought up, Matthew, about the Optimus bots, but it plays out for the battery side also for the vehicles. And so the biggest thing that any automaker is trying to solve for is size, weight, price. Boom, 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 every single time. If we are able to satiate an entire industry with wireless charging, and also publicly as well, just the reality of that is that you're not going to need to have as large as battery packs, and the improvements to the overall range per kilowatt hour, it just continues to be an important matter as well. But as costs fall, improvements on efficiency and use of these different types of materials that are going into batteries, plus the fact that you could size them down, which brings down weight on the car, which will improve the cars just by the circular logic of that, will improve the car's mileage per kilowatt hour. That is a model that every automaker is trying to solve for. We believe wireless charging does solve for it eventually. The timing for that is really the most important question that everybody's trying to find an answer for. So there's a model that it goes, well, does it happen whenever people have it at their homes and in some kind of public type of arena, the way that things have been set up for plug-in charging for superchargers and other DC fast charging networks? It starts to, but what really allows for that to take off is the ability to drive and charge at the same time. And we're not talking about it being interlooped into every major streetway and roadway. No, you shouldn't do it like that. And in fact, if you did it that way, you would just kind of use a bunch of materials and lose a bunch of money for no reason. It wouldn't be infrastructurally sound and economically sound to do it that way. But what we can tell you is that the technologies that we've been developing with our partner over at Oak Ridge, which is Oak Ridge National Labs, we've been developing technologies that allow you to charge as high as 200 kilowatts while driving at highway speed. That is something that we have been in the background working on for a few years now. They've been working on it even a few more years than we have. What I can tell you is this: 1 mile of highway speed, call it 60, 70 miles per hour, will give you an additional 8 to 10 miles of range. And so if you were to do that calculation and just think about some of the high concentrated areas that we have already in the United States, and I'm not even going to talk globally right now, in the United States, especially call it between San Jose to San Francisco, you need somewhere between 3 to 5 1 mile strips to be able to charge tens of thousands, if not even hundreds of thousands of vehicles per day for their entire power that they would need on a daily usage on average. And we know this being in this side of the business, most people are not driving their vehicles more than 35, 40 miles per day, 90% of the year, even higher percentage than that for the average driver in the United States. So that means then coming in and coming out in mass, being able to charge on commuting kinds of highways, interstates, bridges, tunnels, and things of that nature. The costs in terms of infrastructure per mile, the technology or the product cost is, anywhere from $250,000 to $500,000, depending on how it's produced. And so you add in the additional cost for the general type of cement, underlayment, asphalt, bitumen work that you have to do, but you can eliminate the rebar because the components of the actual wireless charging system structurally create the soundness around the infrastructure as just a general nature of how it's built. It's predominantly a bunch of copper cabling, specialized copper cabling, but still it's copper cabling. So it creates a bit of a rebar effect as a result of that. And the systems that we have been designing for are drop-in, call it Lego block sets, but giant cement Lego block sets. That makes us a bit different. It's a composite, or you can say an epoxy-based cement system that also has ferromagnetic material in it. And everything in this is going to get very material. So I apologize, this is going to get a little engineering and scientific, but hopefully you can keep up with it. So there's these really great new composites and materials out there today that can help to improve the overall cost structure of drive and charge technology, known also as dynamic charging. If we take that and we cement in, call it these copper cabling and all these other pieces of equipment into that, you can create these Lego block sets that are approximately 1 meter wide by 2 meters long. And that allows for you to be able to, as an infrastructural application, because anybody that only thinks it's about selling a product needs to learn what solar works as then. If that's what it was, and it was only about producing and selling a product, it's all about the application in these kinds of things. It takes, only a couple seconds to produce a single solar panel, but to put that onto your roof can take a half a day. So the point is we don't want to cause there to be a problem for us to be able to get to that point. The way that we're doing that is through a lot of unique composites and materials that cost down the system, that makes it part of the infrastructure that allows for us to be able to rapidly deploy it and do it in a range of about $250,000 to $500,000 per mile. If you did that and you added in the additional costs of layment, asphalt, road work, call it all the construction workers and everything, you're looking all in between $2 to $3 million per a mile maximum. If you did that for the stretch of road between San Jose to San Francisco, and did that every 8 to 10 miles on at just in even the HOV lane, you would only spend somewhere in the range of $50 million to be able to charge all those cars en masse on the way in and on the way out. And what that does for batteries, coming back to that whole equation, is it reduces the size of the battery load significantly, not to mention the tires, suspension, all the other things that come with the batteries. As a result, that creates obsolescence or increased cost to be able to support those larger battery systems. So this isn't a one-stage kind of technology. I'm really happy to be able to have the conversation today, but I just hope that everybody that's listening understands this is a phase-in situation. It's gone from fringe to trending because, to be very honest, Tesla got in. Now, automakers that are not Tesla are fastly trying to get wireless charging into their production vehicles in the next 2 to 3 years as a result, because they typically are fast followers. We phase in bi-directionality, so it reduces costs and helps to levelize total cost of energy, LCOE. And then we get on to the whole nature of things of where can we get a little bit more extraction of the best parts of what wireless charging could provide, not just into fleets and all these things, but eventually the eventual nature of this is that we get into a larger infrastructure rollout. Starts with static charging at the supercharger locations. So you'll be able to choose, do you want to get outside and brave that cold weather that day and chip off the ice off of that supercharger? Or do you just want to pull up to the wireless charging pad and get the same amount of power without any difference? I think most people are going to choose to stay inside the comfort of their cab rather than trying to chisel away on the cords. But it ultimately gets to this point where we can see a real in-road application. We did a model for I-40. If we did one lane the entire stretch, which is about 2,500 miles, if we did one lane one way and one lane the other way, about $2 billion of total infrastructure. And now transit, we're talking about like semi-trucks and all these that start to convert over to electric platforms, and then not to mention all the commuters never have to stop to charge. And the cost of them is about 40% or less the cost it would have been if they would have stopped and charged at plug-in charging stations.
That's the dream. We'll get there. We'll get there someday. So we'll go for a little bit longer. We have a couple new people joining now. For those of you who joined, if you have a question, just request to speak. For those on the speaker board, just unmute yourself. We're doing hands-free mode. So I see Omar has joined. Feel free to ask any questions. Quick summary. We've been discussing wireless charging. The efficiency of charging your EV wirelessly versus plugged in is very similar. You're talking maybe a 1 to 2% difference, so it's negligible. Cost to add wireless charging to a vehicle is in the hundreds of dollars, not the thousands of dollars. We're seeing wireless charging start to be adopted by large fleets. There are cities where things like buses operate on wired charging. There's overhead wires that charge these electric buses, and that is certainly a great example of where wireless charging could be extremely efficient. talked about robotaxis, how, Franz said last year, essentially they will have to be wireless charging. We discussed bots, how bots could operate 24 hours a day. They don't need to be plugged in. So anyone else who would like to ask a question, please raise your hand or unmute yourself. For those who haven't heard of Hevo, check out Hevo.com. So Hevo makes their own wireless charging equipment. They're working with some auto manufacturers that are not Tesla. Personally, myself and Emmet Peppers were long-term investors in this technology, and excited to see it start to come to market.
Yeah, hey, sorry, I really wanted to attend this space, but then I realized that we had this other space that we were supposed to do at the same time. So I'm here now. I mean, I love wireless charging. I think it's really becoming a huge thing that I think is going to really answer a lot of people's questions about EV charging and how it's going to fit into their life. Tesla's now confirmed that they're working on adding wireless charging to their vehicles. Franz, I think, confirmed that in Jay Leno's garage or something. So I think it's an important part of the story, especially as we look at self-driving cars and how they're going to charge themselves. Wireless charging is a really elegant solution to that.
Welcome aboard. And I'm sorry I didn't catch your name.
Omar?
Omar, hi. Jeremy McCool, nice to meet you. Yeah, there's some things that are going to happen that are going to reshape the entire industry. We're talking about EV and EV charging 2.0. And 1.0 got the job done to get the early adopters. We had to. And all of us early adopters had to deal with it, right? Thankfully, we did. And look where it's landed us. We all made bets, one way or another, as a consumer, a designer, developer, a creator, whatever you might be in this world of EVs. If you've got an EV, you are an early adopter, and the world is grateful to you for it. They just don't know they're supposed to be grateful to you for it yet. The reason why I say that is because we had to go through all the bumps and bruises and the challenges of trying to figure out all the hard things. If you drove anything that was not a Tesla in the last 10 years, God bless you, because we all know what that meant. And I'm one of those people. I've driven both sides of it, and I'm grateful to have seen what it looks like on all ends of the spectrum. And the spectrum is wide, and it's radical. It doesn't even make any sense. You got one side of the spectrum, Tesla superchargers reporting 99.95% uptime. It's remarkable. And you got the rest of them reporting as low as 20% or even greater downtime. That's unremarkable. Somewhere in the middle of that is where a couple of companies like Hevo spur it up from, by the way. The reason why Hevo needs to exist, or any other wireless EV charging company, forget about Hevo for the moment in the topic of this, is because we create the nexus for EV 2.0 to exist. There is no EV 2.0 without wireless EV charging. And at the heart of that is going to be a couple of key components. One of them is always going to be around the actual technology itself and its capabilities, but what it does to enable all these amazing things that these EVs can and will be able to do. We're not talking about a hard to achieve technological hurdle anymore. It was. That's why we spent 10 plus years as an industry trying to develop this technology to make it where it can meet the price targets, and it can meet the efficiency targets, and it can meet the qualification targets for automotive grade technologies. All these things had to come into place. Otherwise, it's not a real technology. It's a good science project that you can find at a university. We're not a science project company. And we're not that kind of focus. What we believe in wholeheartedly is an accelerating electric vehicle adoption and modernizing the grid. That's it. That's our mission statement. Has been forever. And I can
So,
tell you,
Jeremy, let me ask you something,
yeah,
because when I talk to people about wireless charging, the number one thing they say right away, anybody who understands the tech, is, well, isn't it just much less efficient? What do you
yeah.
say to that?
Yeah, so we went through this earlier in the conversation. It's about 1% to 2% difference in terms of efficiency loss versus plug-in charging. At this point, what we see is that from grid to battery, we're going to see a max of about 95% You can even potentially go up to 96%, but we're just saying 95% because that's what we know is very achievable for wireless charging. We've been certainly certified at that already. We've been tested with these kinds of efficiencies, third party, by major automakers, et cetera. Plug-in charging is going to be, on average, from grid to battery, 97% maximum. Level 2 AC charging in your home can even be in the low 80s, by the way, from grid to battery because of all the heat loss and conversions and things that have to happen on the vehicle side from going from AC to DC to the battery pack. So we're right in the mix of what you would see negligibly, as Matthew stated, or right around parity of plug-in charging now with wireless charging. And that's because of all these really important things that happened over the last 3 to 5 years around the technology, especially new power components and things that have come out because of other use cases and customers and things around semiconductors that have made switching parts much more efficient, and other parts of designs and architecture that have increased efficiency and reduced the heat loss as a result. So efficiency isn't a matter anymore. And people also argue is the price. So something, and I brought this up earlier, and I was trying to key in on it. Something about wireless charging that's really important is how much difference there can be in the total cost of the system. At first, in the level 2 variety of that, if we compare it against a level 2 plug-in charger that you put in your home, you're going to put a level 2 charger in your home. It's going to cost you equipment-wise about $700. If you live in California, your extra cost for having somebody come and install that for you is going to be somewhere between $1,500 to $2,500, depending on what part of California you live in. And I'm just using California as an example because it's easy to do this. Well, the cost for the vehicle equipment, or for the wireless EV charger, is going to run between $1,000 to $1,250. But if you total cost that thing with also the installation cost, the difference now is only about 10% of cost difference, total equipment and installation for the level 2 charger. And if it's from Hevo, I can't guarantee this from anybody else, it will power up to 11 kilowatts and bi-directionally. So that's a uniqueness to us, is that we very keenly believe in the idealism and what you can get from having a bi-directional system that can power back into your home, and what it means to the overall cost structure of your energy.
So let me ask you something. There have been efforts made, I assume, to standardize this. Are there differences between different EV vendors? How do I, as an OEM, know sort of what standard to embrace? Is there an SAE standard here?
Yeah, it's called J2954. It's the universal standard for wireless EV charging. It was published in October of 2020. So Hevo was the first company in the world to actually qualify for it. We qualified for it back in January of 2020, right before the pandemic. Then we got UL certification in August of 2020. In October of 2020, the publication that was finally released from SAE J2954 was publicly published. And then from that point forward, everything started to march ducks in a row towards automaker involvement and getting some automakers to start moving towards development programs that are now leading to series production programs. So you will see vehicles with wireless charging that are non-Tesla in the next 2 to 3 years. But when we are talking about specifically Tesla, we have to anticipate, as they've done every single moment that they've ever been alive as a company, is that they may do some things that are different. And we hope that they adopt in the SAE J2954 standard. We would hope that for everybody, not just because of us as a company. We care about the universal approach of charging, period. And so what we don't want to see is a CCS and ACS situation develop as a result. Nobody wants to relive that again. That's not going to be a way to accelerate EV adoption, back to the mission statement. So we want to make sure that Tesla, if they decide to not go that route of SAE J2954, that whatever they're going to do, we are able to find a way to interoperate with them, because it's going to cause more harm than it is going to help if it doesn't happen that way.
Yeah, I think standardization is definitely going to be crucial here. because I really like the idea of wireless charging. There is something really elegant to it, even if it is a little bit less efficient. Because you think about like my friend who just got an EV, and I'm trying to teach them how to charge. And I go, okay, so anytime you're at a grocery store or whatever, they lived in an apartment, they didn't have charging in their apartment yet. So I said, okay, anytime you're at the grocery store, you're at the mall, you're at any location that has one of these level 2 chargers, just try and plug in while you shop or do whatever. And they go, "Oh, well, I can't find it." Then when I can't find it, you got to take the connector and put it in. And some of these payment systems are finicky. They're asking you to sign up for an app. And it's just such a painful process just to get the thing plugged in and starting to charge. That wouldn't it just be so much simpler if you could just drive over the pad? It could negotiate wirelessly and, bill you somehow, and you just go. I think it could be a much better experience, but it seems like there's this chicken and the egg problem
There is.
where, okay, why would I add the cost to put this into my vehicle if there are no chargers out there? And why would I build a charger if there's no vehicles that have it? So, how do you see that sort of chicken and egg problem being broken and this starting to really take off the way we expect it should?
Yeah, so there's only really one way to do that. Somebody has to make a bet on wireless EV charging from an automaker side. If you don't have automaker adoption, it doesn't exist. Aftermarket can only exist within a niche of potential customers. It doesn't get you to the bigger target of what you're trying to achieve with this. And so whenever specifically the automaker that really helped to elevate this is Tesla, and they made a decision to acquire Hyperion about a half a year ago. That put everybody else on notice. It was a major wake up call, a major wake up call. In fact, I would tell you, it moved the technology from fringe to trending. And because of that, it's made everybody else that we've been working with in the background go, oh, hey, we were actually ahead of this. We were smart. We took some risk to do wireless charging and development with you guys, but now we are going to go all in on wireless. And that's legitimate statements that we are being given now from other major automakers that are not Tesla. It took Tesla, frankly, making it real. And once they did that, everybody else could fast follow as a result. So now we're in a position, Hevo is in a position, because we are the only SAE qualified and UL certified technology, and we've met all these other parts of it, size, weight, price, and we have an entire global team dedicated to automotive, which is unique actually in wireless EV charging. We've been able to win business with major automakers, and to get to the point is other automakers having it on their vehicles will help to push Tesla to continue their program to put it on their vehicles, and eventually this amalgamates. We will see some kind of transition occur where you will have not only the option to put it in your home, you're going to be able to charge it in public. And the public infrastructure side of charging is the pain point of this industry. You very articulatedly told the story of what makes plug-in charging terrible. There's a massive amount of problems, painfully. Let's solve for it. Wireless does that. In fact, the vehicle can operate as a digital wallet so that even if you're not driving it in the future and it can park itself, it can still charge itself. And that was transacted properly because the vehicle is the digital wallet. It is an encryption key, as you would put it that way. And nobody had to be there to do that. But when we think about the bigger, how do you get this out into the market? Trigger one was somebody needed to qualify all the different certifications. We did that. Trigger two, Tesla had to get in, and they did that. Trigger three is now all the other automakers are trying to figure out their wireless charging strategy on the fly. If they've been involved with us, they already have a track and a path to getting to wireless on actual production vehicles in the next 2 to 3 years. Who else is going to try to take that step forward and that leap forward now? The more of these that we can tie into a consortium kind of focus, it allows for us to then push the infrastructure side. And so I can tell you, one of the major automakers that we're working with is responsible for supporting the deployment for all these other, call it 3 to 5 major automakers' public charging infrastructure plan over the next 3 to 7 years. And you can bet now that wireless charging is not a subset. It is part of the primary plan for that. So when people can see wireless charging available in public spaces, just like supercharging did for Tesla, wireless charging, we believe, will do that also for people to want to have the wireless charging on whatever vehicle they're driving. And we want that to occur as fast as possible, but we're working within the limitations of making sure automakers are buying in, adopting in, meeting all those automotive requirements as a supplier to them. And then in addition to that, working together to deploy this as an infrastructure plan, not only into people's homes, but also into the grid side on the hyperpower or the extra fast charging cycles that of technology that we have. So just so you're tracking on, we have technology that goes to 300 kilowatts.
Wow, no way.
Yes.
I
So
had heard that wireless charging could really only do level 2 speeds.
no, it's an unfortunate unfortunate data point. There's 3 data points that are common right now in the public knowledge sphere, and we're constantly having to fight it off, which is wireless charging is inefficient and highly inefficient versus plug-in charging. Not true. Certified, tested, approved by major automakers and third parties and national labs around the world. That is in fact no longer the case. That it's much more expensive. In fact, it's about parity. It's going to get close. Maybe won't get exactly there at level 2, but because here's the interesting thing about wireless charging. When you get to higher power, and approximately the threshold is somewhere around 50 kilowatts, when you get to about 50 kilowatts or so, you cross a threshold of cost, where now wireless charging starts to become cheaper by total material cost versus plug-in charging. And there's a reason why. We use significantly less raw materials because the same size pad, which is 1 meter by 1 meter, remains to be the same whether we go from 6 kilowatts all the way up to 500 kilowatts. In a 1 meter square, our design that we have for our 300 kilowatt system theoretically limits at 1.5 megawatts. We are not limited by power. We're limited by batteries' capabilities to be powered at the levels that we can actually power it at. There are no differences in that case. And the cost differences, once we get to 50 kilowatts and above, we can see our cost for our materials now already at 300 kilowatts. Our cost of materials is less than $10,000 at lower volumes. If we're at higher volumes, we could potentially get our cost of materials below $5,000. You can't do that with plug-in charging. And you're not going to be able to do that.
Wow,
If it's
that's
okay,
fascinating.
if I can hit one piece, and I'm sure there's more questions. Something that came up in the previous discussion that Matthew brought up was, if you have a fleet, and he was telling a story of a fleet that is refuse trucks in New York City that's trying to do an analysis of wireless charging versus plug-in charging in a fleet yard setting. He brought up the point, you don't have to run these cords over through the fleet yard over this big patchy area of parking. What's not stated in that, though, and that is an important piece, is that in these kind of compact full fleet yards where you've got tens, hundreds, even thousands of vehicles that get corralled into, they don't have an inch to squeeze out left, right, forward, back. They're butted into each other like a bunch of little Lego bricks. When you add plug-in charging as a complexity to that, you got to not only put in the plug-in charging pole, But now you got to put in the bollards around it that helps protect it from getting hit when people are backing up. Every single fleet manager that we have talked with for the last decade has told us that they're going to lose somewhere between 20 to 25% of their fleet yard space because they have to put in these cables and columns and bollards. And they can eliminate that massive challenge by having wireless charging, because wireless charging is streamlined. You can just put it in as a manhole cover that's surface mounted, or if you're paving over a brand new fresh, area, you could even put it underneath the pavement if that's available to do. But it eliminates a lot of those core challenges, so they can get all their fleet vehicles back into the fleet yard as a result. They don't have to put up all these cords and cables and bollards and systems. So I just wanted to circle back on that piece.
Yeah, so to those listening, please request to speak if you have a question. We have Captain Ellie who has a question, so please unmute yourself. The other speakers, we're in hands-free mode, so feel free to jump in anytime.
Thank you, and thank you for the space. I have one quick question. It might be a stupid question, and I guess either Omar or Jeremy can answer. Can you please help me to understand just the physical process of, for example, Tesla? What is it that they need to change in the car in order to basically comply with this technology? Is it just a question of magnets and cables? Because I have no idea what's involved in this process. And maybe some other people here don't know either. So that would be nice if one of you can do it. Thank you.
Yeah, Captain Ellie or Eli?
It's just Ellie. Thank you.
Ellie, yeah, sure. Ellie, thank you for the question. So on the vehicle side, there's a package that goes onto the vehicle for wireless charging that is a receiving coil. It's about the size of a medium-sized pizza box. So that includes the coil and the additional rectifying technology that converts AC to DC, so the battery receives DC direct. The equation of this is that with the facts that most EVs don't have a lot of parts on it, there's a lot of space on the bottom of the vehicle, but to standardize it, standards show that, and especially the SAE standards show that the placement of that pad will obviously be on the bottom of the vehicle, and it'll be flush mounted in, so you're not going to see it. It'll be covered by the underbrush guard that is typically underneath any of these kinds of vehicles. But that standard package will go straight up and between the front two tires. And so there's been a lot of test studies done to create a database and a sample size of what happens with people that have that pad in the back of the vehicle versus the pad in the front. It looks like visibly, as people are doing their parking alignment part of wireless charging, if they're doing it themselves, it's easier to visualize the fact that you're pulling up to a wireless charging pad or even backing into it. But as long as it's in the front, it's much easier through even your mind's eye, because you can't actually see it whenever it's on the ground. You're pulling your car over it planarly, right? So we have done a lot of tests. We've had dozens and dozens of test subjects try our technology from around the world, major automakers, et cetera, et cetera. I would even say hundreds of test subjects would be the right answer there, that have tested it, tried it, and our parking alignment works very easily for a driver that's not doing it with any driverless assistance. It's done through visualizing through a software app that we developed. Our hardware, because we do electromagnetic resonance, so resonance is the key. Our hardware product line is known as Resonant, and our software, because we help people to complete their journey, our software is called Journey. So those are our two primary product lines. On the hardware side, it's Resonant. On the software side, it's called Journey. So the Journey app supports you being able to visibly understand when you're pulling up, if you need to go a little forward or a little bit back. And you can also see the same visualization through an LED display. We have automakers now that are working to bring that core part of our kernel software into their in-dash displays, so it's all inside their own environment, and it's gorgeous. I've seen it. I know what it looks like. We've done some projects with folks already to see what that's going to look like. Having that in the instrument panel so you can visibly see in the instrument panel that you're coming up, kind of think of it like a beacon, coming up on the beacon, and then it shows you being matched in the right place, and all you got to do is put the car in park. At that point, the charging automatically begins. That's all you have to do. And the final part of this that really takes it to the next stage is when you add in the driverless assistance. And for sure, there's no reason that anybody that has FSD in their car should be plugging in their car right now. If you have spent the money to get that remarkable upgrade to using those incredibly high-powered, wonderful camera-based systems that they have on those cars, there's no reason why you need to be doing parking alignment yourself. The car will be able to do that automatically for you. So to kind of come back to your question, Ellie, there's about a medium-sized piece of box that goes between the front two tires of the vehicle, flush mounted. You won't see it. There's a brush guard that covers it just like everything else. It weighs. It depends on the power level, but because there's different components and things you got to put in for different power levels. But it'll weigh somewhere in the range of 25 pounds to 50 pounds, depending on the power level. We can go up to 300 kilowatts, even above that, with bi-directional wireless on your vehicle side readiness. And that piece of equipment should only cost you maybe $2,000 for an upgrade for it if it's not already standard packaged into the vehicle. That's at the highest power level. At the lowest power level, 11 kilowatts that we will begin offering
Is that
commercially.
bi-directional standardized too?
There's a standard ISO 15118-20 specifically required to the communications and all the other things that must be done standardized for wireless EV charging. And that's a constant development right now. I would tell you that the technology that we possess for bidirectional has a high efficiency level, meaning if we're putting 95% max efficiency into your vehicle, you need to expect at least 95% coming back into your grid system. So the communications is the piece that must happen. There's a constant, I would say, updating that's happening right now from that point of view. But bidirectional wireless charging, that side of the actual hardware and all the things that need to exist for it exist already today in highly competitive performing modes versus plug-in charging. However, there's a communication because you don't have a plug, right? So there's no connected communication. The communication between those two systems is where we're going to spend a lot of time over the next couple of years defining that more. But ISO 15118-20 is the standard specifically for that to be done. And we've been working on it for quite some time now.
You're talking about the handshake?
Yeah, exactly. Because it's not just the communication. Like we can do the handshake all day long. That's the communication between vehicle to grid is fine. But it's also the communication that supports the grid willing to accept the power back in. So the question is, do you do vehicle to grid or do you do vehicle to home? If you do vehicle to home, then it's much easier to kind of kick it off actually, because then you're not having to take into consideration all the extra communications that must happen on the grid to accept that power and then to roll back your meter, if you want to put it that way. It kind of technically, if you can think of it like that. Versus if your grid goes down and you live in California and everybody in California knows you're expecting to see the grid go down a couple times a year, your batteries are on your vehicle automatically the best backup generator that you have. If you have an electric car in your garage, if you parked over a wireless pad, the switch on should be automatic. And if that does that, then there's less communication requirements to be able to feed your home power versus the communication requirements to be able to have the grid accept that back in.
All right, Fudbass, come on up with your question.
Yeah, I was just wondering because you were mentioning about the wireless charging and how if you have this wireless charging, it's more convenient for the companies. For example, they can lower their cost. It's only about 10,000. But for consumers, they might not realize that, for example, if they weren't in the space, they might not really know. For example, Omar didn't know before that wireless charging is actually almost as efficient as this wired charging. So I'm wondering, with all the FUD that's going on about EVs being hard to charge and all the headaches, I'm just wondering, why would we try to complicate things with wireless charging? Would we, for example, when you have all this supercharging that is already wired, and then you're going to introduce, for example, these wireless charging, would consumers have to now pick between, when they go to a supercharger, having to find supercharging that fits with their vehicle? For example, if you have a wired vehicle that's only suited for wired, then you can only go for specific superchargers. Well, if you have the wireless version, you might not be able to go to these superchargers. So is Tesla going to be able to convert these wired supercharging stations and maybe also be able to include wireless in there as well for example, vehicles that have these capabilities as well? So that's an important consideration. I was just wondering. And for example, if you have these vehicles and let's say you're trying to build these supercharging stations and it is cheaper to go for wired, but you're also building, for example, these wireless ones, is that also reducing the amount of economies of scale that you can achieve? Or is it just a better approach to kind of go all in on one, or just provide both approaches to fit all vehicles?
Yeah, Fud, thanks for that question. I'll break it down to a couple pieces because it has a couple components. So when we're talking, there's two pieces to this. So we'll start with the kind of pricing formula first. The pricing formula for this is that when we're talking about level 2 charging, the on-vehicle cost is only a couple $100. When you're talking about high power charging for 300 kilowatts bi-directional, all that could range into like $1,000 plus part of that for the equipment on the vehicle. However, the grid side equipment for an 11 kilowatt system could be anywhere around the range of $1,000 to $1,250 versus an existing $700 average cost for a plug-in charger. But when you get into the higher power systems, higher power 300 kilowatt systems today for plug-in charging average over $100,000. We see a pathway to be able to get that cost to $25,000 or less at retail, and still have a very high margin to be able to grow a very, very comfortable business out of just high power systems. So to the second part of your point, Bud, the wireless charging application for the actual grid connected side for supercharging, because that's really what you're bringing up. If you have both wireless and plug-in charging on your vehicle, do you choose to go to the wireless supercharger, or do you choose to go to the plug-in supercharger? Well, we think that if you have wireless on your car and you have wireless available at the supercharger, why would you get out to do the extra mess of trying to figure out how to plug in that car and deal with all of that to get outside? I would imagine that most people want to do wireless where it's available. I think that's the commonality of human nature, is that we will find the path of least resistance. And because those plug-in chargers that already exist already have all the high power interconnects, there's no reason why they couldn't just come back to those same locations and add wireless charging to every single one of those existing supercharger connectors. Meaning you've got those independent supercharger kind of stations that you see from Tesla as an example. You've already got all the power interconnect there. It's really easy to do an add-on wireless charger. So you install the pad, and then probably if it's in a public location, you're going to do that as a surface mount. As a flush mount, meaning that you're at least going to have it be flush mounted into the asphalt. You may even just go all the way under the asphalt and pave over it and just put a dyed green dot on where that wireless charger is in that space. But adding that additional cost to the supercharger, if you have a suite of 10 supercharging stations at one location, you could do the upgrade for wireless charging at that location for under $250,000 for all 10 locations. You use the same interconnect. And I'm talking about cost of labor in this too. So I'm taking high cost of labor that you would probably see in the likes of, again, using California as a kind of standard of terminology here. So if you're using California as a standard for their cost, for construction costs as a standard, to go put in 10 supercharger, 300 plus kilowatt wireless chargers in the same parking space. So you have both the cable and the wireless in one space. Total labor and cost of equipment, $250,000. And I bet, because of knowing how Tesla operates, they could probably figure out how to get that down to under $150,000, even $100,000. So it's a matter of cost of labor more than it is actually cost of equipment in that equation. And what I'm trying to tell you is, FUD, if you pull up to a supercharger and your supercharger has wireless or plug-in, and you got wireless or plug-in on your car, why in the world would you ever get out and plug that car in? I think you'd probably take the more elegant solution with wireless, wouldn't you?
Thank you. Do you also figure that is it possible for, let's say, a car to use both features at the same time and maybe improve the charging rate, or is that limited in terms of how, I guess, the wires are connected? You can only take from one source at a time.
Yeah, we hear this question come up sometimes. The limitation for a charge is really based on the battery. So if the battery is only able to achieve a certain C rating, meaning that most cars today, there's only a few models that can actually charge over 300 kilowatts today. There's 300 kilowatt plus chargers out there, but there's only a few models that can actually charge on those cars. And be very honest, that may not be so much true for all those cars that state that they can do that as well. But we expect that these passenger vehicles will be able to do that, and we're seeing new innovations on technology side. So what I'm trying to get to on your question is, if you got a 300 kilowatt wireless charger and you got a 300 kilowatt plug-in charger all in one set, doing wireless and plug-in together, your vehicle's still not going to accept the higher power because you don't have a battery that could accept 600 kilowatts max power in that case yet. We think that it'll get there, and one of the ways that you could do that as a matter of scientific/engineering, we see a pathway here where higher power can be achieved, especially in these kinds of settings where you want to get a much faster, quicker charge to be more competitive against filling up your vehicle at a petrol station, which is a matter of minutes. The only way to really get there right now, based on current technologies that exist, I know everybody's going to probably think steady state, but I'm not going that route. I'm going with the capacitor set. So if you have a capacitor, a supercapacitor, if you want to call it that, if you have a supercapacitor, a small bank that can receive very fast power and then trickle into the lithium battery pack, that is probably the fastest way to mobilize higher power in these kinds of vehicle applications. And that technology doesn't need to be created today. Supercapacitors do that today. You don't need to have a whole battery meaning the entire vehicle battery be supercapacitor. You just need to have a certain component of it be a part of it, be a supercapacitor. You high power that system, and then you could do megawatt power. That wouldn't be a problem. Supercapacitor will take it. And they're also, by the way, self-healing. So if there's ever any damage done while you're doing high power, the supercapacitors are going to self-heal, which is really remarkable when you think about the technology of that. But anyways, that then could trickle into the battery pack that's lithium that would give you the better range and performance for more the longer driving side of it. But we haven't seen a company really take on that yet. But we've had some people flirt with it, with the idea of doing high power, ultra fast charging, half a megawatt or higher, or even a megawatt. And again, theoretical limit on our wireless charging pads, 1 meter by 1 meter, is 1.5 megawatt. We are doing testing and development today for 300 kilowatts. But if we were able to do 1.5, or say we were able to do one megawatt on a supercapacitor, so that it would give you enough power to power into your vehicle an extra 50 or 100 miles, and then the rest of your battery pack equates to another 200 plus miles or something like that. That equation is very strong in terms of what the cost balance is of that. But that's just one way to do it, is because it's existing technologies that exist today to do that. We'll see what other battery technologies come out. Hopefully, I know I went way beyond your question, Fudd, but I think it's important for people to understand it's not a matter of us not being able to charge your car. We can charge your car as fast as you want us to. The battery can't accept it. And so what needs to happen is batteries need to get better so we can charge your car faster, not the other way around.
That all sounds incredible, and especially with the supercapacitors, it reminds me of how all of this started for Tesla with the purchases they've made over the past few years, and it just seems like the chess pieces are coming into play when hearing you speak about that. So that's very interesting.
They're smart, to say the least. I admire the engineers of Tesla a lot. They are keen on a couple of key pieces that really matter. One being they always cost down. It's in their mantra, the algorithm, quotationally, right? Cost down components to its bare minimum and then put 10% back on it. Increase cycle rates so you can produce it at volume to get the cost down even further, but improve the efficiency of the system. Reduce churn so that you don't have obsolescence and things of that nature. And then once you've achieved that, you go into automation. And we all know about Tesla's manufacturing hell, and they went the opposite. They literally did the opposite of that. And then they end up just ripping out all the robots and then setting up a tent city and doing a bunch of handmade vehicles just to get to their 5,000 per week vehicle target that they had to get to. So what we know is that Tesla's going to figure out some things in this. First thing, they've got the world's greatest data collection, period. And they've got FSD, and they've got over 1.5 million vehicles, 6 million vehicles, of course, total, but over 1.5 million vehicles utilizing some form of driverless assistance today, that they're able to now use that information through a neural network based kind of solution to create even better methods of FSD as a result. You take that kind of data and you power that with the trillions of tweets that are now within the control of the founder of all these things that's bringing this creatively together. And you add in all these other pieces of the pie that they already have kind of shelved. You can see real quick that they're going to put something together that packages it all in. I like the idea of seeing the vehicles not only use the FSD for bringing the vehicle to the parking space, but actually using the vehicles to align itself, park, stop, charge, then also be able to determine whether or not there's an opportunity to arbitrage power back and forth. They have the inbuilt systems to be able to do that. And everything they're doing on the automation / neural network / AI side of this is going to play in their favor. And there's no argument about that. The most important thing that Tesla is an AI company. And I don't think anybody can debate that anymore. The question is how they're going to use it to improve the entire user experience, especially around this whole structure of automating wireless charging. They're going to get it figured out in a fast clip on that. Better than anybody, at least at first. And then eventually everybody will try to figure out how they did it, and they're going to try to track on to that. And then the first followers and the fast followers behind them are going to try to catch up. But they're going to have that, and they have that already in hand. And I saw they were trying at one point. I heard there was a company that was trying to acquire the supercapacitor company that they acquired. So they had made a supercapacitor acquisition a while back, and they acquired a company, which we know now, Wi-Furion, for wireless charging. And they've got all this other stuff now with FSD. They're going to package all that together very smartly. I admire their engineers. They've got some really incredible tools at their fingertips that they can put together for this.
Yeah, man, that's it's truly incredible.
So we're probably, coming close to the end of the space. If you have a question, please raise your hand. Also, be sure to follow the speakers on the speaker board, especially Jeremy. You can send him questions at any time. If you are interested in investing in Hevo, feel free to reach out to them. It's not investment advice, but I personally am invested in them. So if there's any last questions, please jump in now before we end. So go ahead, Brian.
The space, the proximity between the two coils, there must be a limitation there, right?
Yeah, Brian, good question. So average vehicles will be somewhere between 4 to 8 inches above ground. That's kind of the sweet spot somewhere around 6 inches. You can put that in centimeters and call it 15 cm. And so when you look at that as an equation, what you're solving for is basically the power ratio, the inductance ratio, and then determining whether or not you're within a power percentage, in other words, efficiency percentage to be able to transfer power. The max power range that we can achieve with the efficiencies that we want to achieve, 90+% always, is going to be, we've done projects with 11, 12 inches of distance, and it's still been able to do that as recently in just the last 18 months. We did this actually interesting project. It was very much a, I got to be careful on everything I say here. So it was one of those kinds of, you get a set of keys tossed to you, make it happen project. And it came from one of the biggest communication companies in the world. Where I was sitting, we had 2 weeks to prepare a Mach-E, a Ford Mach-E with wireless charging. We'd never worked on one before. And not only just to get it ready to do static charging, but to do dynamic charging, meaning it could drive and charge at the same time. And to deliver it to Detroit and then do demonstrations of it doing static and wireless, dynamic, meaning driving at the same time, doing wireless, static, and dynamic charging. So it had to start static and then get onto a stretch where it could also charge while it was driving. I want to just kind of point out something. Until that point, nobody had ever been able to do both. We had 2 weeks to do it, to do both static and drive at the same time. And we had to do it in front of all the major executives of multiple companies. So live demonstrations can go very wrong. We've seen that even with Tesla and with Franz and Elon throwing a metal ball at the bulletproof glass, which was pretty awesome. But what we were able to do in just 2 weeks of time, we were able to do over 20 demonstrations live, 2-hour demonstrations at a time for all the executive brass of multiple major multinational conglomerate companies without a hitch. And we were doing the drive-along technology with the pads being under 4 inches of concrete. So the total distance from where the pad was underneath the concrete to the vehicle pad that was on the vehicle was 11 inches. And here's an interesting thing. When we were static charging, the distance was all the way down to about 3.5 inches. So when there was a pad on the ground that it started at for this demonstrator, and it would park, charge, and it was only a couple of inches. Then it would pull out and then drive over the strip and then charge at almost 3x the distance. And to be able to have a technology that can flex between those types of different gaps and ranges and be able to do static and dynamic, and nobody had ever done that before. That was the first of the first. To be able to do that all into one package and do it also on demonstrations live for executives, we were able to do it because we found something. We discovered something as a result. These kinds of things are very important to do when you're in the design development process. You got to go flex some muscle and be willing to take some risk and blow something up. And we did that. Thankfully, we didn't have a problem with it, but I've seen and we have been a part of programs that can do all those kinds of distances. So, and have done those just even in the recent 24 months. But most cars are going to be less than 8 inches.
Yeah, so I'm thinking the Cybertruck with the 16 to 8 inches of ground clearance, you would probably want to lower it down to get better efficiency when you're charging on the pad, right?
Actually, I don't know the answer to this, and I'm sorry to say this. is it what is the distance of that Cybertruck? I thought it was 8-9 inches. Is that not right?
Minimum ground clearance, I think, is 8, and
Okay.
maximum is 16.
And it has that active suspension like they have probably in all their cars, where you can lower it while going, and et cetera, I believe, right? So yeah, the answer would be, it'd be great if it was at 8 inches. That would be perfectly suitable, because that's really where most of their cars are anyways. And we've been testing with Teslas now for about 8 years, 7-8 years now. We've been doing Tesla integrations and testing with Teslas. They're fundamentally pretty easy to do once you figure out how to. Again, I got to be a little careful how I say this. Once you figure out how to communicate to it, and there's only kind of one way to do that. You got to learn how to listen. And once you learn how to listen to it, you can move it on. That process for everything else becomes pretty quick. So yeah, to answer to your question, I totally hear what you're saying. Yeah, the Cybertruck would need to probably have that active suspension drop to that 8-inch clearance, so that we can make sure that we were able to charge it. But I always think of things, and we always think of things in a macro sense. We don't want it to just be able to charge at home. We want it to be able to charge in public. And then we want it to eventually be able to charge while you drive it, and charge at the same time. And also be able to do that bi-directionally, all in one package. So putting all that complexity into one vehicle package is really the most important achievement that will be made in wireless charging, which I can tell you that we've been able to do. And that means less cost, less weight, et cetera, et cetera. So you'll be able to do it with that Tesla Cybertruck. That's not an issue. That height variance, yeah, at 16 inches, no, that's probably outside. That's too extreme. But at 8 inches or so, that'll be just fine.
Thanks, Jeremy.
You got it. Thanks, Brian.
One of the earlier comments, you were saying that it wasn't the limitation with the charging speed. It's not that you can't get it to be fast, but rather you don't want to damage the battery. Is there a possibility that you can give consumers the option to charge it really fast, and then let's say every year or whenever the consumer decides, they can just go to a Tesla service center and decide to swap their battery, so that they have the flexibility? Let's say you really want to charge your car really fast, and for a certain day maybe you have an errand to run right immediately after, you can immediately charge really fast and maybe degrade your battery a little bit. But for other times you don't have to, but every year or so you can just maintenance it by going to a service center and getting it fixed. Is that a possibility, or do you think that would be
Yeah,
too complicated?
actually, we learned something through a decade plus of charging, which is that lithium-ion batteries and the cells have a potentiality. I can't say this for every single cell manufacturer, but we have tested against cells that have that have the capability to self-heal. There's some certain things that you need to do to it to make it self-heal. Actually, what we envision doing for the customer on that is we'll kind of like sort to the degree that you get an update for your phone or even for your Tesla. If you have a Tesla, it says update coming up. Our message to you is self-healing session coming up in 3 days. And what it ultimately means is that we're going to have to slow charge your car. And if we do that, there's the potentiality of being able to heal back some of your power ratio that you've lost due to the faster charging cycles. The battery pack swap out game, just in general, the infrastructure requirement to carry a bunch of battery packs. Let me speak to this part. You can't even really get a fire department to bless off on allowing you to store lithium ion inside anywhere. So lithium ion is a very, very dangerous type of composite. We'll just say that there's a certain amount of storage that you're allowed to have, et cetera, and then it has to be away from it's got to be isolated and quarantined and all these other things. So a swap out situation at a dealership becomes challenging because you've only got so much square footage before you lose out on that for other options. I would just say that you're probably going to see a better form of battery technology or multiple applications of different battery technologies, like we talked about earlier, come into coexistence together, and they should. There's no reason for them to not. It reduces weight, cost, and all these things altogether as a compacted design. The power components are there to be able to already handle it. By the way, one of the fastest ways to get to higher power without it damaging your vehicle is to go from 400 volt DC to 800 volt DC and eventually to 1200 volt DC. And the reason why is because you're not pushing as much current into it, because voltage is fine. It's a flow rate, but current is the push. And the push is what actually damages the battery cell itself. So if you were to back off on the push and increase the flow, the result of that is that you can flow in more without the push, and therefore you might be able to achieve a higher C rating on these batteries. We do know that there's several major automakers, and we're involved with a few of them. There's several major automakers moving towards a 800 volt DC plus battery pack design. So the question then becomes, to your point, Fudd, the question becomes, are you going to pull up to a supercharger that's going to have 400 volt DC, or are you going to pull up to a supercharger that has 800 volt DC type of charging application? Or I should say, in that case, ready availability. And the good news is that it doesn't matter, because your battery automatically converts that in the step before it. So you're not going to have a situation where you have to DC convert different types of power. So my point to you on all this is to say, better technologies are coming out on batteries as a result of going to higher voltage from 400 volt to potentially 800 and 1200 volt, which reduces the push on those batteries. Therefore, you have a less challenging total life cycle problem with batteries as you go on in life. You should be able to expect at some point that batteries go from 2,000, 2,500 total cycle rate to something like 5,000, 10,000 total cycle rate. What that means then is that you get a battery pack that you should be able to see 500,000 miles or more be driven on that same battery pack without significant diminishment to your range. And that's going to happen through a couple different methods. One's going to be through the higher voltage that can be put onto those batteries. And the second part is going to be that a mixture of different kinds of batteries that help to eliminate those things. And then the third is that you could potentially even go into healing cycles on those batteries. But that's to be remain. Obviously, that there remains to be seen. There still needs to be a lot of additional samples ran on that to create strong enough evidence for that to happen. Matthew, how are we looking?
Yeah, I think that's probably all the questions we have. So I think, we're getting to the top of the hour. We should probably pause it here. I'd again like to thank Jeremy from Hevo and everyone who came up and asked a question. I'll be posting the replay to this, so if you missed the start, you can replay. The replay will automatically be here on X, and then I'll also post it to YouTube. If you have any other questions, tweet to Jeremy, check out hevo.com, and hopefully we can all see wireless charging in our cars soon. So thanks again, everybody. Have a great day.
Thanks, everybody. Thanks, Matthew.